Today we're going to do a last sort of mole lesson, wrapping up the two formulas that we have learned to help us convert between numbers of particles, numbers of moles, and then finally masses. And I know it says lesson number 5 begins here, but we really aren't learning anything new today. We are just simply taking the two formulas that we have learned and we are going to consolidate them and maybe give you an amount of particles and ask you to solve for a mass, or maybe give you a mass value and ask you to solve for the number of particles. So just a reminder of the two formulas that we have learned. So there's our moles equaling particles, which again, we don't love the term particles, so we would use either atoms or molecules or formula units, depending on whether it's an element or a compound. And then we can divide by Avogadro's number. But we also have another mole formula that deals with masses. So our actual mass divided by our molar mass. And because the common variable between these two formulas is little n, which is moles, then we can use both of these formulas and solve any kind of question that involves masses and numbers of particles. So there are a couple of examples that we're going to run through, and you are encouraged to go through the resource note. Here's a nice little schematic or a diagram that they have for you on converting between the two. And a little write-up here. You should be reading that. But I'm going to go through these examples with you. So it says here, what is the mass of 3.567 times 10 to the 23 molecules of carbon dioxide? So we haven't seen questions yet where we're dealing with mass and molecules in the same question. But we can solve these because we know these two mathematical formulas that we can use. Now, if you want, okay, they list all kinds of steps here for you in the resource note. And you are welcome just to click on these and go through them, but I'm going to take you through the actual calculations, okay? And that way you can see how I would set this up. And it might just be a bit more helpful for you to see me go through the work. And then there's a second example here, that same thing I'm gonna go through. So I've copied these examples and I put them on a Jamboard, and we're just gonna run through the examples together. Now, let's just review the two formulas that exist to help us convert between mass, moles, and particles. So we learned this formula. So moles is equal to particles divided by Avogadro's number. And remember that capital N is particles, but we don't use that term. We're going to either use atoms or molecules or formula units, depending on the substance. And remember too, if you're a triangle person, I am not a triangle person, but if you are, you can set these up in a triangle. Okay, so this is how you set it up. And whatever is side by side here on the bottom, you can multiply those two variables if you know both of them. If you know a variable in the numerator and in the denominator, then you are dividing those variables out. Okay, so if that helps you use the triangle, I don't tend to use them. I tend to use the mathematical formula. And then the other formula that we know is the one with masses. So the one with actual mass divided by molar mass. And same thing, you can put that into a triangle exactly the same way. So moles, mass, molar mass. And notice that the common variable for both of these is the mole. So in a question where you are given, the mass of something, let's say, and you're asked to solve for the number of particles, you're going to have to solve for moles. Okay, it's the only way because it is the common variable between both of them. So let's go through and do an example together. So what is the mass of 3.567 times 10 to the 23 molecules of carbon dioxide? So we don't know what our mass is. We're going to put that down as our question mark. We're not sure. Right here, they're giving me the molecules of carbon dioxide. So carbon dioxide is a compound. This is why they're going to use the term or the unit molecules. And this is my capital N value. So let's just get that down. 3.567 times 10 to the 23 molecules. Now, let's write our two formulas over here so that they are handy and we can see them. Okay, so there's the one formula. Here's the other with masses. Now, let's go through and, what do we know? What do we not know? So little n, we do not know. Okay, they have not told us the mole value. They have told us capital N. This is my molecules. Okay. They have not told us the mass. We have to solve for that. And we do know Na, that's Avogadro's number. Okay, so that's the constant, 6.02. We can write that down. So that is 6.02 times 10 to the 23. So you'll recall, they will not give you that number. They assume you know it. And because this is a compound, we're going to call this molecules per mole. So for 1 mole, there would be that many molecules. And then in the other formula, we do know molar mass. Again, they won't give it to you, but you can solve for molar mass. So let's solve for it right now because we're going to need it. Let's go over to the periodic table and let's look up carbon. Here's carbon right here, 1201, and then oxygen is 16. And we remember we're going to multiply those values depending on the numbers of atoms. So you only have 1 carbon, so 1201 grams per mole. And then we're going to multiply by add on 16 and then add it on again. Okay, so you can set it up a couple of different ways. I'm just adding everything together here. And this works out to be 44.01 grams per mole. So I have everything that I need, but I still don't know moles. And so this is where I'm going to have to start in my calculations because I know big N, I know Na, I'm going to solve for moles. And then when I get that, I can insert it into the other formula and then solve for mass. So number your steps, folks, when you're doing this, okay? It just makes it a lot easier to see what's going on. And so we want to solve for the moles of CO2. And we're going to take molecules divided by Avogadro's number. And we're going to sub it in. 3.567 times 10 to the 23 molecules divided by Avogadro's number, the constant. 6.02 times 10 to the 23 molecules per mole. Okay, so I know I'm not going to have a mole. I have a smaller number than I do if I have 1 mole. So let's divide that out and see what we get. Drop my calculator. So 3.567 EXP 23 divided by 6.02 EXP 23. And I'm getting 0.5925 moles. Now, normally I would get you to chop that to 2 decimal places, but this isn't my final answer. So let's hang on to 4 decimal places, maybe 5, and don't clear it out of your calculator. Okay, it's not wise to do that because you're just gonna have to enter this number back in, and then you might make a typo or hit the wrong button on the next go. Okay, so now we know my mole value over here. Now we come to this formula, and I need to solve for lowercase m. So I'm going to cross multiply molar mass by moles, and I just calculated moles, so this will be easy for me to do. So we're going to solve for the mass of CO2. We're going to take moles times the molar mass. We just calculated the moles. Oops. So 0.5925 mole. And then we're going to multiply that by the molar mass, 44.01 grams per mole. So hopefully you left your mole value in your calculator from the first calculation, and then all you have to hit is times 44.01 grams per mole, and I'm getting an answer of 26.08 grams. Okay, so here you would round to 2 decimal places. So hopefully this is clear as to what we're doing. Again, the first formula that you need, it'll depend on what do you have 2 variables that you already know that you can either divide out or multiply. It'll all depend. And then again, you'll solve for moles, and then you'll just stick that mole value into the other formula and keep going. Here's our second example. So it says chlorine gas can react with iodine to form iodine chloride. How many molecules of iodine chloride are contained in this sample? So 2.74 times 10 to the negative 1 grams. So some of this information that they give you is not relevant to us. They're telling us how they form iodine chloride. They do it through a reaction. But I'm kind of tempted just to cross that out because I don't need anything about chlorine gas and I don't need anything about iodine. They're asking me about the product, iodine chloride, and there's its formula right there. So it says how many molecules? Well, molecules is capital N. We don't know what that is. They told us the mass. Let's write that down. So 2.74 times 10 to the negative 1 grams. We know that if they're dealing with masses, we're going to need molar mass. So let's solve for the molar mass. Oh, I'm going to put the formula in here of ICl. Okay. And I'm going to go over to the periodic table and I'm going to look up the molar masses of each of those elements. So here we are. Here's chlorine, 35.45. Here's iodine, 126.9. And I only have one atom of each, so we're going to add those up. 126.90 grams per mole, and I'm adding on 35.45 grams per mole. So let's get that total. So 126.9 plus 35.45 gives me 162.35 grams per mole. Okay, so that should be enough. We don't have Avogadro's number written down, but we should be starting to get the hang of the fact that we know Avogadro's number. So here are my formulas again. So I have N is equal to capital N over NA, and then I have moles equaling mass divided by molar mass. So which one do I have to start with? Well, you start with whichever one you know two pieces of information for. And so we don't know moles, don't know what it is. We know little m, we know molar mass. So this is a good one to start with. And over in the other formula, we don't know molecules, we don't know moles. We do know Na, that's Avogadro's number. But this is the one I have to start with because I know two pieces of evidence for it. It's different every time. You got to pay attention and know what you're dealing with. So number one, we're going to figure out the moles of ICl, and we're going to take mass divided by our molar mass. So 2.74 times 10 to the negative 1 grams divided by 162.35 grams per mole. And we get an answer of 2.74 EXP negative 1 divided by 162.35. And you should be solving with me, okay, so that you make sure you're punching this into your calculators properly, getting the right answer. So I'm going to say 0.0001687 moles is what the calculator is saying. And we're not going to round because we need this value. We have to now come over to the second formula. I have to solve for molecules. So I'm going to take Avogadro's number and I'm going to cross multiply it by my mole value, which I now know. I just calculated it. So let's come back here. We're going to solve for the molecules of ICl, and we're going to take moles times Avogadro's number. So I'm going to need 0.00168. I'm going to round that, okay, moles. And then I'm going to multiply by Avogadro's number, 6.02 times 10 to the 23. And that unit will be molecules per mole. And then we'll be able to come up with our final answer. So hopefully your mole value is in your calculator, and now all we have to do is times it by 6.02 EXP23, and I'm getting an answer now of 1.02 times 10 to the 21 molecules. Okay, so now we would round to 2 decimal places. Watch your units. Okay, moles are canceling out. And you come up with a value of 1.02 times 10 to the 21 molecules. So again, your main resource note goes over all of this, but I just thought maybe it'd be helpful for people to see me actually carry this out by hand. Okay. If you have any questions, reach out, but you can go back to your summary note, your main resource note, and you're going to see there'll be some calculations you need to do and submit to the portfolio.